Welcome back to the deep dive. Today, we're tackling something absolutely central to sysadmin work, locking down your network perimeter on a GNU Linux system. And if you're heading towards your Red Hat Certified System Administrator cert, well, you'll want to pay close attention. We're focusing laser sharp on what you actually need to know for the exam.
Exactly. That's the mission here. We know certification is the goal, so we're not just glossing over things. We're going to build this up piece by piece.
Making sure you get not just the what, but the why behind Red Hat's choices.
Right. It's all about practical skills, real mastery you can use.
Okay, so here's the plan. We'll start with a quick look at firewall history.
Yeah.
Where these tools came from. First filters, then application stuff, just for context.
Good idea. Understanding the evolution helps make sense of the tools we have now.
Then we'll look at how things diverged a bit in the Linux world. RPM-based systems versus Debian-based. Different paths.
Yeah, RHEL and Ubuntu took different approaches there.
And then the main event, Section 3. We dedicate pretty much all our time to the absolute must-know hands-on skills for firewalled, using Firewall CMD. That's the RHCSA focus.
Non-negotiable for the exam. Okay, let's jump into that history then. Way back, late 80s, networks are starting to connect everywhere. Boom, we need defense. First up, packet filters.
The original gatekeepers, right? Super basic. They only looked at packet headers.
That's it. Source IP, destination IP, ports, that kind of information. But the key thing, the defining characteristic, they were stateless.
Stateless, meaning no memory.
Exactly. Zero memory of what happened before. It saw a packet, made a decision, saw the next packet, made another decision, completely fresh.
So it couldn't tell if an incoming packet was like a response someone inside asked for?
Nope. Couldn't distinguish between a legitimate reply and some random, unsolicited attempt from outside. Every single packet was judged on its own. A big security hole, obviously.
Which explains why the next step, early 90s, was such a game changer, the stateful firewall.
Massive leap. These things actually maintained a connection table. They kept track of ongoing conversations.
Ah, okay. So they could see an incoming packet and go, wait a minute.
I know this conversation. This packet belongs to that SSH session Bob started a minute ago. Let it through. That context awareness. Huge improvement.
Made them way more secure.
Oh, absolutely. Became the industry standard pretty much overnight.
And then, as the bad guys got smarter?
Hey, yeah. Threats got more complex. So we saw the third generation emerge. Application layer firewalls, sometimes called proxy firewalls.
These operate at a much higher level, don't they? They're looking inside the data packets.
Exactly. Not just headers or connection state. They understand protocols like HTTP or FTP or SQL. They can inspect the actual commands or data being sent.
Filtering based on the application itself? Pretty sophisticated.
Very. Okay, so that's the big picture history. Now let's zoom into the Linux world. For years and years, the core engine doing the actual packet filtering inside the Linux kernel. That was the NetFilter framework.
Right, NetFilter. And the tool everyone used to talk to NetFilter to set the rules?
That was Iptables. For a long time, on basically all major distros, RHEL, Debian, you name it, Iptables was the way. Incredibly flexible, incredibly powerful.
But I sense a but coming.
Oh yeah, but notoriously complex. You had to manually build these intricate chains of rules. Order mattered. One mistake could break everything.
And making changes was tricky.
Very. Often, applying a new rule set meant flushing the old one and loading the new one, which could, briefly interrupt connections.
Oh?
Or worse.
I've heard horror stories like accidentally locking yourself out remotely.
Been there. Applied a new Iptables rule set over SSH, forgot the rule to allow SSH itself, connection drops, silence. Panic.
Yeah.
Not fun. It was just static, rigid.
Okay, so that pain point, that static nature, is that why Red Hat invested in creating Firewalled? To solve that specific problem?
That's a huge part of it, yes. Iptables was fundamentally non-dynamic. Firewalled, introduced back in RHEL 7, is different. It's a high-level daemon.
The background service.
Right. It runs continuously, managing the underlying rules. The key benefit, you can add or remove rules, change zones, whatever, without restarting the whole firewall service and without dropping existing connections. It handles the updates dynamically and atomically. Much safer.
So on the Red Hat side, the standard became Firewalled, and the command we use is firewall-cmd.
That's the one. Firewall CMD is the front-end tool you interact with.
And under the hood, Firewalled isn't replacing NetFilter, right? It's managing it.
Correct. It's an abstraction layer. Originally, Firewalled managed Iptables rules for NetFilter. But more recently, especially since RHEL 8, it's mostly transitioned to using NFTables as its backend.
NFTables being the modern successor to Iptables in the kernel.
Exactly. More efficient, better syntax. But the beauty is, Firewall hides that complexity. You still use the same consistent firewall CMD commands. The administrator experience stays simple.
Okay, so that's the RHEL path. What about the other side? Debian, Ubuntu.
They went a different route, generally standardizing on UF.
The uncomplicated firewall.
The name really says it all, doesn't it? Canonical developed it specifically for maximum simplicity.
Like, how simple are we talking?
Well, compare opening the SSH port. With iptables, you'd need a potentially long, complex rule-specifying protocol, state, port number. With ifdo, it's often just // done.
Wow, okay. That is uncomplicated.
But it's important to remember, just like firewall, UFS is also an abstraction. It's a user-friendly wrapper managing the underlying kernel rules, whether that's iptables or nftotals.
Good context. So we know about iptable's legacy. We know if it exists.
But now, put those aside. For the RHCSA exam, UFW is irrelevant. Iptable's knowledge is, well, mostly historical context now. Your entire focus must be firewalled and firewall CMD. Practical, hands-on precision.
All right, let's get into those practical skills. Core skill number 1, understanding and managing zones. This seems fundamental to firewall.
Absolutely fundamental. Zones are the core concept for organizing rules. Instead of applying rules interface by interface or port by port, you group rules into these predefined trust levels.
Trust levels, like public for the internet, internal for your trusted LAN.
Exactly. You get zones like public, home, work, internal, DMZ, even drop, which just silently drops everything.
Yeah.
Each zone comes with a default set of allowed services and ports reflecting that trust level.
So the idea is you assign your network interfaces to the appropriate zone based on the traffic you expect.
Precisely. Principle of least privilege.
Yeah.
Your internet-facing web server's network card. That almost certainly belongs in the public zone, which is usually quite restrictive by default, maybe only allowing HTTP and HTTPS.
Okay, so testable actions. What do we need to be able to do with zones?
All right, number 1, check the default zone. What zone applies to interfaces that aren't explicitly assigned elsewhere? The command is firewall cmd get default zone.
Got it. Default zone check. What else?
Number 2, list all available zones and crucially see what services and ports are allowed in each zone or a specific zone. That's firewall CMD list all zones or firewall CMD zone public list all.
Okay, listing zones and their rules, and the big one for configuration.
Assigning interfaces. You absolutely need to know how to tell firewalled, hey, my main network card, ACO, put that in the public zone. Or this other card, ETH1, that's for internal management, put it in the internal zone. That's a core task.
Makes sense. Setting the trust level per interface. All right, core skill number 2. You mentioned this is a common tripping point.
Huge one, both in real life and on exams. The critical difference between runtime configuration and permanent configuration.
Okay, break that down. Runtime is?
Runtime is the live set of rules currently active in the firewall right now in memory. If you just type firewall CMD add service ATTP, that change applies immediately to the runtime config.
Got it.
But it's temporary.
Right.
If you reboot the server or even just restart the firewalled service, that runtime change, poof, gone, wiped out.
Ah, so permanent configuration is the saved version.
Exactly. The permanent configuration is stored persistently on disk, usually in XML files under a set of firewalled. These are the rules that get loaded automatically when the system boots up or when firewalled starts.
Okay, I see the separation. Why is that useful? Seems like extra steps.
It's a safety net. Imagine you're trying a complex new rule. You apply it to the runtime config first, test it. Does it work? Great. Does it accidentally block your SSH access? Whoops.
But if it's only runtime, you can just reboot.
Precisely. Reboot the server. It comes back up loading the old, safe, permanent configuration. You haven't locked yourself out permanently. Then you can figure out what went wrong with your test rule.
Okay, that makes a lot of sense. Safety first. But it means if you want to change to stick after a reboot,
you have to make the change to both configurations, or, more accurately, make the change to the permanent config and then apply it to the runtime.
So every command needs to be run twice. Or, how does that work?
Typically, you add the rule with a permanent flag first to save it. Then you need a way to load that saved config into the live runtime state.
Let's get specific with firewall CMD syntax then. This is exam territory. Adding predefined services like SSH or HTTP.
Right. To allow HTTP traffic right now in the default zone, let's assume it's public, you'd run firewall-cmd add service HTTP. That's runtime only.
Okay, runtime done. Now make it permanent.
Immediately follow up with firewall cmd add service HTTP permanent. That writes the change to the disk configuration.
Same logic for removing a service, just remove service.
Yep. Remove service FTP for runtime. then remove service FTP permanent to save it.
What about specific ports? Not standard services, but like a custom app running on port 8080.
Same idea, but you use add port or remove port. Critically, you must specify the port number and the protocol, TCP or UDP.
So for port 8080 TCP?
It would be firewall CMD add port 8080 TCP for runtime.
And then firewall CMD add port 80 to TCP permanent to save it.
You got it. Run it once without permanent for the live test, then run it again with permanent to make sure it survives a reboot.
Okay, hold on. So I've run the command with permanent. The change is saved to the config files on disk.
Look.
But the live runtime rules haven't changed yet from that permanent command, right? How do I sync them up without rebooting?
Ah, the crucial step. This catches so many people out. You've made your permanent changes, they're saved. Now you need to tell Firewall to load that saved configuration into the active runtime configuration. The command for that is firewall CMD reload.
Reload, okay. That's the bridge between permanent and runtime.
Exactly. Reload tells Firewall, discard the current runtime config and load the saved permanent config right now. It does this without dropping existing connections, which is vital for production systems. It smoothly applies your saved changes.
So the workflow is make permanent changes using permanent, then run firewall CMD reload to make them live.
That's the standard safe workflow. Make all your permanent adds and removes, then reload ones to apply them all.
And verification. Always verify. How do I check what's currently active and what's saved?
Good point. To see the active runtime configuration for a zone, like public firewall CMD zone, public list all.
Okay, that shows services, ports, interfaces for the live rules.
And to see what's saved in the permanent configuration for that same zone, just add the flag, firewall CMD zone, public list all permanent.
Perfect. List all for runtime, list all permanent for saved. Allows you to confirm your changes took effect both now and for the future.
Mastering that cycle. Make permanent changes, reload, verify both runtime and permanent states. That is the absolute core of using Firewall effectively and safely.
What about more complex rules, like allowing traffic only from a specific IP address?
Good question. For things beyond simple service port opening, Firewall has rich rules. They offer much more granular control, similar to Iptable's power source destination IPs, logging, specific actions, but using a slightly more structured Firewall CMD syntax.
So Firewall CMD isn't just for basic stuff. Rich rules handle the advanced cases, probably less common on the exam, but good to know they exist.
Exactly. Know they exist for complex scenarios, but master the zone, service, port, and runtime permanent tree load mechanics first. That's 90% of it.
Okay, that feels like a solid roadmap for RHCSA prep. We went from stateless filters way back when.
Through stateful firewalls, application firewalls.
Saw how Linux tools evolved with Iptables, then the split to Firewalled on RHEL and UFA on Debian Ubuntu.
And landed squarely on the essential firewall skills. Zones, interface assignment, services, ports.
And that absolutely critical runtime versus permanent distinction tied together with reload.
Nail those firewall CMD operations, understand zones and persistence, and you're in great shape for that part of the exam. It really comes down to precise command line work.
All right, let's wrap up with a final thought for you, the listener. Imagine this. Your server's under attack, maybe a DOS flood from a specific IP. You quickly jump in and use firewall CMD to add a runtime rule blocking that IP. Success. The attack stops. But what 2 immediate command line actions must you take right after that successful block to ensure your server stays protected if the power flickers and it reboots 5 minutes later?
Think about making that block survive the reboot. Think about persistence. The answer lies in the commands we just discussed. Good luck with your studies.